I work with customers around the world focused on automotive. So these are billion-dollar companies. And I've been on projects where it might be 5, 6, 7 iterations at the cost of hundreds of thousands of dollars. In fact, I would say they're probably near billions that are wasted every year by teams that are designing a circuit board that they are absolutely unsure whether will pass EMC. And so they go back in emergency mode, redesign the circuit board, refabricate it, push to get it through manufacturing, pay expedite charges for everything, and beg for time in the lab with no confidence that it's going to work again. So that's not engineering. That's just hoping. Since I've learned about fields and how do you manage fields from my mentor, Ralph Morrison, I never even think twice about my boards. When I go to final test, I'm absolutely convinced that it's going to pass EMC. And my biggest example is I had avoided doing very high performance designs. I have a tools group within NXP where I develop products that our customers use. I fill the missing holes in the development tool chain, and I do some pre-silicon emulation work where we do a group of chips that are going to match functions for a new device that's coming out. So I got an email about 1.5 years ago that said, we need a pre-silicon emulator for a network control chip. So here's what you need to do. So I work with our applications team. This has got a layerscape processor, 1.6 gigahertz operation. The 1 volt supply had a 7 amps per microsecond power supply requirement. It had an Ethernet switch, 400 gigabytes of DDR4. It had an Ethernet controller. It had PCIe. It had SerDes. It had everything you can imagine. And they were all tied to a group of SAMTEP connectors. So to make things more fun, I had a 0 length matching requirement because this board had to pretend it was a chip. So all of the SKU allowed had to be given to the motherboard. I reviewed the schematic from the applications team. On the layerscape part, they had put in 28 ferrites and inductors as pi filters all over the place for the input power supplies for the various micros, especially the layerscape part. I took all those off because I fully believed that energy management is fundamentally placing enough energy in the right place on the board to make sure that you deliver energy every time the clock switches. And the applications team were like, no, you can't do that. And I went, well, I can do that. It's my board. So we sent the board off. First it worked, which was really good because my team is that talented. Passed EMC the first time. I had never done a DDR4 chip. I had never done a layerscape design before. But I just looked at the part and I followed the rules that I had been able to create over the last few years. So what I want to try to give you is a quick glimpse into the idea of fields, because it's not electrons flowing in wires, it's the electromagnetic field that we are building things to manage. And try to help you get a little bit different perspective so that when you make choices in your layout, that they're going to be focused on field management, not simple things like current flow.